So today's lesson, 4.1 was kind of the intro to exponents. 4.2 was using negative exponents. 4.3 was the scientific notation. 4.4 was adding and subtracting exponents. Which remember we kind of had to like shut our brains off a little bit because when we're talking about multiplying we have to have like bases, and we'll go over this is actually a great like review lesson for some of the stuff that we already talked about. But anyways, I kind of thought that since 4.4 was since 4.4 was adding and subtracting polynomials, that maybe 4.5 would be multiplying and dividing. Well, it's only multiplying. So today we're going to talk about multiplying monomials, which we talked about. Definitions are huge, right? We're going to talk about multiplying a monomial and a polynomial, multiplying two polynomials, which I don't know why there's two number twos there. I taught 3 classes yesterday and still didn't fix it. And then multiplying using something called the FOIL method. And then I'll show you a method that I actually used. It's called the Punnett square. I kind of like it better, but I'll let you decide. You guys can actually decide whichever one you want. Okay, so we're talking about multiplying monomials here. Let me make sure I got my pen. Just kidding, that wasn't the right button at all. But in this case, we have negative x cubed times 9x squared. So what we're going to do is we're going to take this negative x cubed and we're going to distribute into there. So the way that I do this is I actually break it down by taking my numbers in front of my variables, which are called my coefficients, and I separate those from my exponents. And the reason why I do that is because negative 8 times 9 gives me negative 72. And then here we have to remember, like bases, what do we do with the exponents? Well, we actually add them. So in this case, your final answer would be negative 72x to the 5th. Over here, again, I'm going to add in some ones that aren't there just so we can kind of see what's going on. So what I mean by that is that this y doesn't have an exponent on it, but I'm going to give it an exponent of 1. There's no coefficient on this xy to the 4th, but I'm also going to give it a 1, and then I'm going to put a 1 up here. And why I do that is when I break these down, I have to realize that 2 times 1 is happening for my coefficient, that I have an x squared times an x to the 1st, and then I have a y to the 1st times y to the 4th. So then 2 times 1, that's not hard, right? 2. But when I do this, I have to remember that there is this 1 exponent up there. So I get x squared times x to the 1st, which I believe is x cubed, and then y to the 1st times y to the 4th, which is y to the 5th. So hopefully that makes sense. That's why I added those ones. Over here, there was already an exponent of 3 there, an exponent of 2 there, so I didn't have to really add them. But here I just did so I can see what's going on. So my final answer over here would be 2x cubed y to the 5th. Okay, go ahead and pause the video and try these ones. Okay, similarly to the last one, I'm going to put a 1 here. I'm going to break these down to negative 9 times 6. And then y to the 1st times y to the 8th, so it should be a 1. So negative 9 times 6, I think, gives you negative 54. Y to the 1st times y to the 8th is y to the 9th. Right? Here, I do 10 times, break it down, 10 times 4, x squared times x to the 1st, y to the 1st, times y to the 1st. So I think I should get 40x cubed y squared. Because remember, like bases, all we're doing is add those exponents. And I like breaking it down into like coefficients, x's, y's. You can just distribute it in, but sometimes it can get confusing. So that's why I like breaking it down. It's easier for me to kind of view it that way just to see it broken down. Okay, so hopefully that made sense. So that was multiplying a monomial by a monomial. Remember, monomials are 1 terms by 1 terms is basically what we're saying there. Now we're going to do 1 term times multiple terms. So remember, just as a review, a binomial had 2 terms. Terms are separated by plus and minus signs. Trinomial is going to have 3 terms. Those are, again, separated by plus and minus signs. And then a polynomial is anything more than that, right? So here, I've got 3x cubed times the trinomial of 2x squared plus 5x minus 6. So what I have to do here is I have to distribute this 3x3 to each part. And that's the hardest part of this, is remembering the 3x cubed just doesn't go to the 2x squared, but it also goes to the 5x and to the 6. So again, I like breaking this down. I do 3x cubed times 2x squared, and then you bring down your sign. Again, 3x cubed times 5x, that's a terrible 5, sorry. Bring down your sign. 3x cubed times 6. So again, what we're doing is we're taking this monomial of 3x3 and we're multiplying it by 2x squared, 5x, and 6. So again, if you need to break these down, you can. I'm just going to go a little quicker this time. So 3 times 2, I believe, gives you a 6. And an x cubed times an x squared, like bases, I'm going to add the exponent. Okay, bring down my sign. 3 times 5, that's a terrible 5, sorry, is 15. And again, I have an x cubed times x. I have to remember that there's a 1 there. So that would be x to the 4th. And then I can bring down my sign. 3 times 6 is 18, and then I just bring down my x cubed. So this right here is my final answer for that when I'm multiplying the monomial of 3x cubed times the trinomial of 2x squared plus 5x minus 6. As far as we're talking about like binomials, there's 3 terms here, right? My first term is 6x to the 5th. Second term is 15x to the 4th. Third term is a negative 18x cubed. Remember, when we're talking about degrees of this trinomial, we talk about the highest exponent. So I have an exponent of the 3 there, 4 there, 5 there. So we're going to talk about a 5th degree trinomial is the technical name for this guy. Okay? So go ahead and pause the video and try this one. Okay, so I'm just going to let the computer do this. They do a really good job of it. So they take the 2x to the 4th times the 3x squared, add the 2x to the 4th times 2x, add the 2x to the 4th minus 8. Now, how I would break it down is I'm going to do it down excuse me. 2 times 3 is 6. X to the 4th times x squared, you're going to add those exponents. 2 times 2 is 4. X to the 4th times x to the 1st, right, is x to the 5th. And then 2x 4th minus times negative 5 would be negative 10x to the 4th. So again, this time we still have that trinomial, but this time it is a 6th degree because the degree of this term is 4, this is a 5, that's a 6. Okay, so we talked about multiplying monomials by monomials. We talked about multiplying monomials by polynomials. What happens if we have 2 polynomials that multiply together? So this got a little confusing yesterday, so I'm going to try to do a little bit better job. And so there's something called the FOIL method. So when you use the FOIL method is when you're taking, so again, so far we talked about a monomial times a polynomial. This is a binomial by a binomial, okay? So in this case, we're always going to have to use this FOIL method. So what that basically means is that we have to take this x and we have to multiply it by that one, and we have to multiply it by that one. So x times x is going to equal x squared. So that is your f, or your first. Okay? Your x times negative 6 then equals negative 6x, and that is your outside. Okay? So we're basically distributing this x to there, and then that x to there. The next time, we're going to take the negative 2, and we're going to multiply it times the x, which gives you negative 2x, which is your insides. And then you're going to do negative 2 times negative 6, and remember, a negative times a negative is, that's a terrible 6, is always a positive 12. So that is your last. So FOIL comes from thinking about you're multiplying the firsts, the outsides, the insides, and the last. Okay? Then what I do is I have an x squared plus a negative 6x plus a negative 2x plus 12. I realize that here I have a negative 6 plus a negative 2. I think I can combine those to give me a negative 8x plus 12. And this is what I get when I FOIL x, the binomial of x minus 2 times x minus 6. So you may need to go and watch that again. So again, FOIL stands for firsts, outsides, insides, last. So you have to multiply the firsts, the outsides, the insides, and the last. And all you're thinking about is that you're basically doing this. You're doing x times x minus 6 minus 2 times x minus 6. So you're distributing that, 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 and that. It's kind of what you're thinking about, but this is just a little quicker way to do it, okay? So what I want you to do is pause the video. This should be an X. I don't know what happened here. This should be an X. Pause the video, try that, and we'll see what happens. Okay, so I'm going to have to do this one. So the first, I think, are going to be 5x times 2x. The outsides are going to be 5x times 3. The insides are going to be negative 6 times 2x. And the last are going to be negative 6 times 3. Okay, simplifying, 5x times 2x, remember these both have an exponent of 1, so this gives me a 10x squared. 5x times 3 is a 15x. Negative 6 times 2x gives me negative 12x. And negative 6 times 3 gives me negative 18. So then when I add them up, 10x squared plus 15x plus negative 12x plus negative 18, I think I combine these two in the middle. So I end up with 10x squared plus 3x minus 18. So that should be my answer. Okay, so again, the first are 5x times 2x. The outsides are 5x times 3. The insides is negative 6 times 2x. The last are negative 6 times 3. And then all you do is you kind of just add up. Now, these middle terms are, in this case, will always combine. Okay? All right, so that's called the FOIL method. Let me show you the method that I prefer. I don't know what that is. I didn't mean to hit that. Oh, man. How do you erase everything? I just want to erase everything. I don't know what I'm doing. Sorry, give me a second. You get to watch me erase every single... Oh, haha, let's do that, Matt. Okay. So there's another method that I use that you might have seen in biology. For me, it's a little bit easier to do because, I don't know, I'm more of a visual learner. So what it is it's called a Punnett square, okay? So here's what you do. Sorry, that's not supposed to be there. So to use a Punnett square, well, the first thing you're going to use a square in this case. I got to get better at drawing squares, sorry. So you set up a little window, okay? On the left side, we're going to put this. So I'm going to put a 5x and a minus 6. On the top, I'm going to put a 2x and a plus 3. Okay? So this is where it gets a little bit confusing. Okay? So what you do is that in order to fill in your boxes, you're going to multiply. So you're going to do 5x times 2x, so this will be 10x squared. In this box, you're doing 5x times 3, which is 15x. You start to recognize some of these numbers, right? Negative 6 times 2 gives you negative 12x, and then negative 6 times 3 gives you negative 18. So basically, to fill in the boxes, you're multiplying, like it's kind of like a little grid, right? So you do 5x times 2x to get this one, you do 5x times 3 to get this one, you do negative 6 times 2x to get this one, and like when I first learned it, I literally had to use my fingers. That's why I did that in the air. So I literally put my fingers on 2x and 5x, and then where they meet, wherever they are multiplied, that's what I'm writing in that box, okay? So then you take everything in your box and you add it together. And that's probably the hardest part. So the hardest part is remembering that to fill your boxes, you multiply. But then once you have your boxes filled, you just add everything together. Hopefully that makes a little bit of sense. So here, let me show you another one. And this is when I really use it, and this is why I really use it. So sorry, we're going to skip this one. This one right here. So now I'm dealing with a binomial of x plus 2, and I'm multiplying it by a trinomial of x squared plus 2x plus 4. So could I do x times x squared plus 2x plus 4 plus 2 times x squared plus 2x plus 4? Yes, because what I have to do is I have to multiply those two times that, add that, times that, for sure. I could do it that way. Or I could just extend my Punnett square. Again, you get to pick whatever you want, but using the original equation, this is an x plus 2. This is an x squared plus 2x plus 4. To fill in the boxes, x times x gives me x cubed. X times 2x gives me 2x squared. X times 4 gives me 4x. 2 times x squared gives me 2x squared. 2 times 2x gives me 4x. And 2 times 4 gives me 8. Bring them all down. combine like terms. I just have 1x cubed there. I have this 2x squared, and I have another 2x squared. So that's 4x squared. I have this 4x and this 4x, so that's a total of 8x plus 8. So this is my final answer. Now, why do I use a Punnett square here? This is like kind of one of those cases where I use a Punnett square. I just like the way it's set up. The hardest thing is kind of that, like I said, remembering that you multiply to fill in your boxes, but then you add at the end. It's kind of the same thing here where you're going to multiply these first, right? And then at the end, you're going to add them. So it's kind of the same thought process. The struggle why I don't use the kind of FOIL, I call it the super FOIL method, is that when I do x times 2x, so when I do this one right here, I'm getting 2x cubed, or 2x squared, sorry. But when I do this one right here, I'm also getting 2x squared. So sometimes in my mind, I kind of run into this thing where I'm like, well, like, I said I already had 2x squared, and then I got another 2x squared, and then it's like, wait, did I duplicate my multiplication? Did I already have that? Do I need another one? And so that's where, like, sometimes I find myself, like, struggling, is that I run into that. So anyways, I like doing this way because even right here, again, you'll get two 4x's. So it's like, it's remembering, like, wait, did I already write that? Did I not write that? Do I write it again? I don't know. So anyways, that's why I like going this route. You can do any route you want. Ultimate goal is to make sure you get the correct answer. So go ahead and try this one. Pause the video. Try this one. And then I only have one more after this. Okay, so Punnett square, again, I don't know. This is what I'm doing. I probably should have said this before I had you pause the video, but if you're struggling setting up the Punnett square, what I would recommend is pausing the video now. Make sure you have your Punnett square set up, and then coming back and seeing if it's good. Filling in my Punnett square, 3x squared times x gives me 3x cubed. 4x times x gives me 4x squared. Negative 5 times x gives me negative 5x. This is a 12x squared. This is a 16x. And this is a minus 20. So I've got 3x cubed. These are the only x squareds that I have, so I'm just going to add those right off the bat. These are the next ones that I have. And then there you go. So that should be your final answer. And then the last one, this one's just kind of for fun. This one is going to be a 9, that'd be crazy. A 3 by 3 Punnett square, which is a total of 9 squares. So I think that's why I had 9 in my brain. But this is m cubed minus 2m plus 1, 2m squared plus 4m plus 3. So I'll go ahead and set that up for you. Pause the video, give it a shot, see what you got. Okay, so filling in the Punnett square, I think you should have 6 terms with your answer here. So this is, what in the world? This is 2m to the 5th. My thing just got small. Anyways, wait, what? I don't know what just happened there. I was writing on the wrong screen. Sorry. I don't know what just happened there. Somehow I wrote on my wrong screen. I don't know. It feels like a Tuesday. Okay, so I think this 2m to the 5th doesn't have any other coparts. Neither does the 4m to the 4th. But I do see an m cubed here and an m cubed there. So 3 minus 4 gives me negative 1m cubed. And then I do see this negative 8m squared plus 2m squared, which is negative 6m squared. And then a negative 6 plus 4 gives me a negative 2m plus 3. So that should be your final answer right there.